Erin, I'll wait for you to respond.
Well, it's nice to chat with you. We've been trying to get in touch for a little while now, so.
It has been. You've been jet setting. So for the folks in Kaggle who may not know, I feel like you're very well known in the machine learning community, but just in case, Erin LeDell is a data scientist at H2O, also a software engineer. Like, you build tools. I don't know. What is your official job title? I should have looked this up.
Yeah, it's kind of a combination of those things, but it's Chief Machine Learning Scientist at H2O.
Yeah, fantastic job title. Erin, you may be familiar with, you've done a lot of work on, obviously on the H2O open source stuff, and you have a PhD in statistics, I think, and your research was in imbalanced classes for binary decisions. Is that correct? Am I close? It's been a minute since I've read.
Yeah, you're very close. I can fill in the gap. So, I did a PhD at Berkeley, and my PhD is in biostatistics, which is actually, it's not really a department. It's a group. So basically, I took my classes in the statistics department and also some classes in the CS department. And yeah, so my research was you hit on one aspect of it, which is some imbalanced class stuff. But mostly it involved figuring out different ways to scale statistical algorithms, and specifically, usually machine learning algorithms, through either algorithmic changes to things or software or hardware or any combination thereof. And I started, I also work a lot in ensemble learning. And so I started working on H2O as an open source project, and that's how I got involved and ended up working here. I started using H2O as a platform for building scalable ensemble machine learning algorithms.
So just a slight aside, and we can sort of pop off of this whenever you want. So you're one of the relatively few people I can think of who I would say is like very much a machine learning person and also very much a stats person. And where would you draw the line between them? Because I usually jokingly say it's like, oh, it's what conferences you go to, and if you're a stats person, you go to JSM, and if you're a machine learning person, you go to ICLR or whatever. Would you agree?
Yeah, there's a lot of, I think, good memes about this, like on Twitter or the internet. One of them I saw was like something about grant size. Like if your grant is like less than 50,000, you're a stats person. If it's like $1 million, you're a machine learning person or something like that. So yeah, I think there's definitely more people these days that I think are coming into machine learning from a computer science background or programming background. So yeah, it's hard to really draw the line. I guess I do see myself as both, and I think maybe the machine learning people, there's more of a focus on implementation and software and scalability and things like that. And from a statistics side, it's more like the algorithm and the confidence intervals and the correctness and other things like that. But I mean, there's a pretty big overlap. And a lot of the machine learning algorithms that people use are created by statisticians. I guess sort of with the exception of deep learning, it's everything else is pretty much created by statisticians. So I think, yeah, we forget that sometimes, but I think we can all be friends.
Yeah. Oh, absolutely, absolutely. It's my background's in social science, or more on the social science side, so I'm always interested in sort of like, what is it that makes these groups different, even though they're doing the exact same thing? Like, what's the difference here? Yeah.
So, statisticians are also a bit more like critical, and maybe even like, you know, it's always like, I feel like statisticians are always looking for like oh, you're violating these assumptions here, or you're not using it properly, whatever. So they're more like sticklers about theory and assumptions and things.
Mm-hmm.
Computer science people are like, I don't
But it
care,
works.
whatever, I don't even care about cross-validation, whatever, like nobody cares. So, and then there's everything in between. So I'm sort of making a cartoon version of each bit.
Wow. Anyway, sorry to come back from that tangent. Do you want to talk about ensembling? Because I know this is for a Kaggle audience. We all know Kagglers love ensembles. We love our stacking. We love our blending. Do you have any pearls of wisdom to share?
Yeah, I feel like Kagglers are like my people. They get it. They get ensembles. They get why they're useful. It is kind of like a specific task or goal in mind on Kaggle. The goal is to win, and you win by having the best model. So that's not always aligned with everything else going on in industry, but I don't know. I think it's something, I guess, that I care about, and so yeah, I think my goal has always been to like get the best score on any problem. So there's ways to combine certain things where you can try to get a good ensemble but have it not be too complex. But yeah, so stacking is probably like the thing I do the most, and that's what I did a bunch of research in a while ago, and what I continue to work on at H2O, and it's a big piece of the AutoML approach that we use as well. So yeah, I mean, stacking, it's pretty straightforward. It's even like something that you can implement pretty easily. So I don't know, is it useful for me to just like explain what stacking is?
Yeah, absolutely. Absolutely. There is, I will say, a lot of disagreement on what exactly stacking entails. So I think it's very useful to have like a baseline.
That's true. So, right. So there's there's different ways to do stacking, and there's different names that have been used over the years. And I think maybe it was you who did like a survey on Twitter or something. I think you asked about it, and people basically just don't agree. So I don't know. And I've read pretty much every paper about stacking, and so I would say historically stacking or stacked ensembles or stacked generalization, those three terms, also the term superlearner, which I'll explain in a minute, all refer to stacking where you use the cross-validation predictions from the base learners to learn the best combination of those together. So essentially what stacking is it's a way of using machine learning to learn how to combine a bunch of models together. And you do that by training something that we call the meta learner, although that term is pretty generic and used in a lot of different ways. But in stacking, the meta learner is a function that takes as input the predictions from the base learners and tries to predict the original outcome. And so you basically need a training frame that has, like, if you have 5 base learners in your ensemble, this training frame would have 5 columns, and then you have n observations, where n is like the original number of data points in your training set. So you did cross-validation, so you get a bunch of cross-validated predictions, and then you train your model on that. So that's the traditional form of stacking. Now, cross-validation, like on big data sets, that can take a long time. So there's other versions of that. So people just maybe take like a holdout set and train the meta learner on that. And so that can also be like stacking, I guess. Then there's other ways, like instead of using a machine learning algorithm to train the meta learner, you can do things where you maybe use like a greedy approach of like tweaking all the weights, and then starting out with some default weights. If you're talking about a linear combination as your meta learner, and then you tweak them all, like then people sometimes, I don't know, sometimes I hear people call that blending, but I also hear blending as like the other thing that I just
With
described.
the holdout set, yeah.
Like, I don't know, maybe we need like a Venn diagram of terms. And then if anyone has heard the term superlearner before, that's another name for stacking. And that term comes from basically what happened was stacking was invented a little while ago, like, let's say, I don't know if it's like 30 or 40, like 40 years ago now or something like that. And, there was papers about it, but there was not a lot of theory but backing it up. Like, why does it work? It doesn't work. And then in 2000, I think 7, somebody named Mark Vanderlaan, who is my PhD advisor at Berkeley, he wrote a paper called Superlearner, which sort of proves all the theory behind stacking and like why is it optimal, and basically a bunch of the math that was missing from that. And so that name comes from him. So that's a name you could hear at Berkeley, but you also maybe hear it other places. There's an R package called Superlearner that I used to work on as well. Eric Polly is somebody else that I should mention. He was the co-author on that paper and the creator of the Superlearner package. So anyway, that's a little summary of stacking. Yeah, and it works well because the reason stacking works is because you want to take a bunch of base learners that basically fail in different ways. So there's not one single algorithm that's always going to be the best on every data set. So it's a good flexible tool, like given some new data set, you don't really know much about it, just to like train a bunch of algorithms and do stacking, and then see how it goes.
And it's, I would, just for like context, I would contrast more ensembling focused sort of techniques with some of the stuff that's going on in NLP right now that I wouldn't necessarily call ensembling, but the idea is that you have a bigger model with more parameters and you train it on more data and it does better, but not necessarily that you have many smaller models that are focusing on other things, on separate things, and then you're taking the results and pulling them down together. And my intuition / experience is that with ensembling, you can get better result with a smaller data set than you could if you had, just a huge neural network with a lot of weights that you would need to update, because you don't necessarily have enough information in a given data set to update all those weights.
Yeah, I think there is a little bit of a lower bound. Like for stacking to do well, I would say you need at least 1,000 rows. So
there was a time when I would have thought that was big.
So just like if you're trying something out and you try it on the Iris data set and it doesn't do well, it's because the meta learning step requires a little bit more information to actually do its job. So, but like you can do stacking with deep learning too. So you can, and I've seen some of the research in deep learning right now is involving a bunch of ensemble techniques as well. So maybe, if you wanted to stick to a pure deep learning approach, or maybe you have, data like image data where it really makes more sense to use deep learning and not anything else, you can still use ensemble, you can still use stacking even. So there's not really a lot of like off-the-shelf tools that do that, but there should be. But in H2O we have some deep learning capabilities, and you can do stacking there, but I don't know of other tools where that's readily available.
So is there anything you've run into recently in a blog post or a paper that you think is especially interesting or that you would like to talk about?
So basically I've buried my head in the sand in terms of like I'm only interested in AutoML lately. So everything it's not entirely true, but I will mention that, like, when you say recently, just a few hours ago, I was having a conversation around like interpretable GAMs, so generalized additive models, which apparently are like, a thing that people are talking about and using, and so that's exciting. So that was a little bit outside of like what I normally think about on a day-to-day basis, but any algorithm to me is interesting because then I can put it in Ensemble and get better results. So that was why I'm interested in GAMs, and if we could, have that in my software and then add it to AutoML, that would be great. But yeah, I mean, I would say things that are interesting. There's a lot of stuff related to interpretability that's interesting to me. I'm not gonna like maybe point out anything specific, but stuff that I've been working on recently is a lot of it is related to benchmarking. So me and it was 5 other people had a paper at the ICML AutoML workshop in June about benchmarking AutoML systems. So something that I've been thinking about lately is just how to do proper benchmarks. I mean, I've been thinking about this for a long time, but my focus recently has been in AutoML. And then once you have these tools to do benchmarking, you can kind of use them as a sort of debugging mechanism for building your own algorithms. So you can use it to sort of probe what's going on in your algorithms and say, okay, what is it about this data set that's weird and why are the results odd? So then you look at it and you say, okay, this was a super wide data set, so maybe that's like a blind spot for this tool, or maybe this one had 500 classes and that's a lot of classes, and maybe that was the issue. And so yeah, I've been reading, I'd like to read a lot of papers about benchmarking, but it's a really difficult thing to do fairly, and there's a lot of choices that have to be made that are like not optimal, and yeah, it's a fun thing though, because it's I think especially as more companies, more for-profit companies are doing machine learning, we need to have strong systems that measure things so that we're getting like reliable information about tools. And there's a term that, I don't know who thought of this term, but I like it. It's called benchmarketing. So, you see things that are like, here's our, tool, and we do so great, and blah, 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 and there's like no reproducibility.
99% accuracy on this extremely imbalanced data set. Yeah.
Right.
Yeah.
Exactly. So yeah, there's a lot of ways to like, move things around so that they look a different way. So anyway, that's been my interest like lately, has been doing a lot of benchmarking and then thinking about the results and like using that to inform what new techniques or like tweaks that I would want to make to like the H2O AutoML algorithm is what I work on, which is the function in the H2O package that does AutoML, which is open source. So.
Yeah, definitely, especially as there are a lot of new AutoML options entering the market. It is, I mean, honestly, we're not, I don't know if you saw the blog post I wrote about an archive paper a while ago, but I think there's pretty good evidence that we're not great at benchmarking just like machine learning research in general that's done like by hand. And benchmarking AutoML systems, like you have to pick a problem that's fair, that isn't going to like unnecessarily be biased towards a specific flavor of AutoML, and that's already hard to begin with. And then how can you deal with the ability of the different systems to handle like variability and change over time, and yeah,
there's a lot of things to measure. So you just have to start with some sensible things. But even just like you said, choosing the data sets is extremely hard, and it skews the results very easily in certain ways. So you have to, that was one of the reasons, like when I'm doing all this benchmarking, I'm doing it with a group of people, not just at H2O. I'm doing it with a bunch of AutoML researchers, because I think we have to agree as a community, like what is a fair benchmark, and I think when you have a bunch of people involved and, you can start to converge upon something that's a bit more fair.
Absolutely.
Yeah.
Absolutely. And I think it hopefully is something that could also help propagate back into the non-manual ML, I guess, the non-automatic ML in terms of how to evaluate systems.
Yeah, I think it's a much harder actually to do it with, like, for AutoML, it's, at least you have some constraints. Like, you have ideally one function that you're running and you're using all the defaults, and then you run it for a certain amount of time, and maybe you give it like a metric that you're trying to optimize. But other than that, you don't have to tweak anything or think about anything. So it actually makes it easier to do fair benchmarking. But a long time ago, I wrote a blog post about benchmarking random forest algorithms, and this was in like 2012, I think. And I think the benchmark or the blog post is no longer on the internet because the company I was working for was acquired. So I don't know, it disappeared. But yeah, just how do you make fair decisions about defaults? Like, how, I don't know. It gets very complicated, and you could just endlessly like argue different points. Anyway, it's hard. It's a hard problem.
It is. It is. I mean, I think that's part of the reason why Kaggle has been successful. It's not necessarily a perfect way to evaluate how good certain, approaches are at a specific problem, but it is a way, and it works pretty well.
Yeah, and you've had a pretty big variety of data sets on Kaggle and stuff like that. So it's all about quantity and just doing massive amounts of evaluation.
Yes. Yeah. It's not super relevant to Kaggle, but the idea of like grad student descent, where you just have like a bunch of people working on the problem, and then you see how far you go.
Yeah, that's great. I have not heard that term before. I would be using it, yeah.
So we got about 5 minutes. I don't want to keep over time because I know you are super busy. But is there anything else you just want to share with Kagglers? Things you want people to think about, or projects you're working on that people should keep an eye out for? Anything?
Well, I guess for Kagglers in particular, so something, we at H2O have quite a few Kagglers working for us. Like I
One or
think
two.
Number is, I think we have 12 grandmasters that work here. So I do get a lot of feedback from them. So they help inform our AutoML strategy quite a bit, and even more so on the other tool that we make called driverless AI. But yeah, I think, for Kagglers, I would love like feedback about H2O AutoML. It's open source, so you can try it out. There's usually somebody puts a kernel up on every competition. But yeah, the part that's, where humans are still quite useful really is the feature engineering side of things. And so I'm interested to see, I'm interested to see if, there's some libraries or like more, let's say, methodologies that for feature engineering that people could come up with. So there's stuff that's like all over the place on every Kaggle competition, but I think what's interesting is formalizing a lot of that a lot of those techniques, and then sort of combining them with like the auto algorithm tuning stuff. And yeah, so I think love to get feedback from anybody on Kaggle about H2O AutoML and if it's working for them, and then ideas about different feature engineering stuff. We do have basically in driverless AI we have automatic feature engineering, but we don't have a lot of that yet in H2O AutoML. Well, we're adding some stuff soon that might help, but. Yeah, what else for Kagglers?
And just really quick, what's the best way for people to give feedback? What's the best channel?
So one channel would be my email, which would be erin@h2o.ai.
ERIN?
Yeah, ERIN@h2o.ai. And then, probably that's the best thing. Like if you're using it and you have some issues and they're code questions, post them on Stack Overflow. We'll see them there. But yeah, if you have like direct feedback about, here's this data set that I tried it on, it didn't do well, or here's this data set that I tried it on, it did do well, like things like that are useful. We are getting a lot of that feedback just from running on these, large set of large set of data sets that we're benchmarking and finding, holes in the system, basically.
Especially with feature engineering, I can imagine like very like discipline subject specific effects that you would want to find out about.
Yeah. So, and also like if people have interesting data sets like this, they find on Kaggle or elsewhere, we're always looking for like a sort of problem area data set. So let's say a data set that has like some columns with, very high cardinality categoricals or something like that, or like lots of missing data, although you can make a version of that quickly by deleting data. But, interesting real world data sets. And also like on the benchmark, one of our sort of criticisms in sort of the related work section of other benchmarks is that the data sets aren't big enough. But we also, I feel, struggled to find big data sets. And so, it's not that people aren't doing a good job on the benchmarks. There's not a lot of good, big data sets out there. So if anyone has data sets that are public that they could send me a link to, I would love to add. We're looking for more data sets to add to our benchmark. And also the benchmark is open source. So if you have an AutoML tool, so this might be good for Kagglers. So let's say you're trying to do your own little AutoML function or something like that. You could benchmark it against all the popular open source AutoML tools that we have in the benchmark. So it's HDrill AutoML, AutoSKLearn, Teapot, AutoWeka. Then we have some baselines of like just running a random forest and things like that. So if you're curious, like maybe you have some ideas about AutoML, you want to try them out against a bunch of data sets, against a bunch of AutoML tools, let us know, or just use the code. I don't know if there's going to be like a links section on YouTube in this video.
Oh yeah, I'll put relevant stuff under the video.
Yeah. So.
Yeah, they'll be exciting. I'm really interested to see what people come up with. I think there's a reason there's so many Kagglers at H2O, and part of it's that the community has a really good insight into what tends to work and tends not to work. So it'll be interesting to see what folks come up with.
Yeah.
All right. Well, thank you so much for meeting with me. I'm glad we could finally make this happen. Yeah, I'll see you probably at some conference in the future.
I'm sure we will.
All right. Great talking with you.
Likewise.
Bye.
Bye-bye.